Great, thanks Barry. So I'm here to give some updates from the Great Lakes Fish Tag and Recovery Lab, also known as the Mass Marking Program, and there's a lot of ground to cover, so I'm going to get right to it. I'm going to talk about how this clicker won't advance. Now I'm going to talk about an outline for the talk. We're going to go through some of the funding updates, some of the updates from what we did this past year in terms of tagging and field recoveries, and then a bit of a teaser slide on steelhead results. Then we're going to talk about some of the results from Chinook salmon and lake trout. Those will form the meat of the presentation. And then I'm going to conclude with a few slides on sea lamprey wounding on salmon and trout. So with that, for funding, I've got a table here that's going to be really hard to read. But basically the good news is for 2019 and 2020, we are anticipating funding of $1.5 million per year, which is what we've seen in 2018 and in a number of prior years, which is what we need to have to sustain the present effort for Chinook salmon, steelhead, and lake trout tagging, as well as the field recovery effort in Lake Michigan and Huron. And this bill that has been talked about for a while, it is planned to be reintroduced into the new Congress sometime soon by Senator Stabenow. So this is still something that's potentially on the table. It didn't move anywhere in the last Congress. We'll see what happens in this Congress. But it essentially would put into text a lot of what our program already does in terms of formally establishing the program in Fish and Wildlife Service. It would provide base funding, so it wouldn't be off of Great Lakes Restoration Initiative funds anymore. It would specify the collaborations we have with our state and tribal partners, and also the fact that we need to make data available to everybody. The big thing is, if this were to be passed, the funding would go up to about $5 million a year, which would allow us to expand the program, have the additional staff and equipment necessary to tag other species, as well as work on other lakes. So we breezed right through the funding. For the 2018 tagging and field recovery effort, just summarizing here what we did in terms of our tagging, we were just shy of 10 million fish in 2018. That top table there focuses on the three core projects. You see the Chinook salmon, lake trout, and steelhead. We do have most of those Chinook salmon. The majority now are 80 only, with some coated wire tagged fish remaining for index sites and for various state projects. And then we do have some 80 only steelhead, I believe mostly due to certain constraints with regards to needing flexibility and where some of those fish may end up. One of the big things we saw at this table last year, we had I think 68 or 6,900 fish per hour for steelhead. That number has gone up to over 7,400 this past year. So with an additional year of experience under our collective belts, we've been able to increase our throughput on steelhead. Things went a little more smoothly in the trailers. And we continue to provide some support on these non-core projects as time and equipment allow to assist the states with some projects on Atlantic salmon in Michigan, brown trout and splake in Wisconsin, and then putting some coated wire tags for presence-absence purposes in brook trout released into Lake Superior. This is a figure showing the time series of number of fish processed in millions by year since the program's inception in 2010. And you can see in most years we're flirting right around 9-10 million fish in total. Pretty big change here when we added on steelhead and stopped the Chinook portion, although you'll see we're actually still processing all those Chinook. They're still getting fin clips, even if they're not all getting coated wire tags. And then the three core species, Chinook salmon, lake trout, and steelhead, forming the bulk of this. I anticipate future years are going to look something similar to the last 2 years until we have another change in terms of priorities. With that, turning right to the field collection effort, we had 13,400 some odd observations in 2018, and part of the rationale for having, I guess we had a little bit of a lower number of collections than say in 2015, 2016. We had a reduced workforce in April and May in terms of the number of technicians we had in the field. But the good news is in 2017 we didn't have anybody out there in 17 or 18, or in April or May. So we were able to get kind of a better coverage this year than last year. And again, the bulk of those collections are going to be Chinook salmon and lake trout, about 4,500 total for each. a little over 1,600 steelhead, a little over, well, close to 2,300 coho salmon. So this is broken down by jurisdiction. And we also had a number of, another record year in terms of number of tags extracted. This number is going to continue to climb as the lake trout from the 2010 and later year classes become more fully vulnerable to the assessment surveys and to the recreational fishery. This is broken down by agency, but the grand total here, we're a little short of 15,000 tags from about 17,000 snouts in 2018. So another solid year for field collections, tag collections, and tagging with the mass marking program. A lot of these summary tables are available in some reports that are outside in the hall. I do want to talk a little bit about some of the additional research efforts that were supported in 2018. We've heard a lot about some of these today already. Collection of diets for the predator study that Dr. Roth just spoke about. Collections of otoliths from wild steelhead to look at their natal origin. So where are the streams that produce wild steelhead in Lakes Michigan and Huron? 2018 was the second to last year of full collections. This coming season will be the last year of full collections for that particular study. Collaboration with Michigan State and CMU to look at natal origin of wild Chinook salmon. Collecting otoliths in 2018 for that particular study. That study, unfortunately, was not funded last year, but we do have a proposal in, again, with the trust this year, and are hoping to enjoy similar support from the states with regards to that effort. And then we continued to collect tissues from sea lamprey, from salmonines to look at sea lamprey attacks and their effects on the physiological condition of salmon and trout. The idea here is to try to get some additional information on utilization of alternative hosts, as well as implications for post-attack survival. And that is another research proposal that's floating around out there that is yet to be funded. So, now moving into the fun stuff. So steelhead, we started tagging steelhead in the 2017 year class. And this past year, we did collect some of these in the open water. We had a total of 7 steelhead. So you can't make a lot of inference from 7 fish, but these are only 1-year-old fish. All 7 of them were 10 to 14 inches from open waters. And we actually did see that 6 of the 7 were collected somewhat far away from where they were stocked. We have 4 fish from southern part of Lake Michigan that were recovered in WM4. 1 steelhead came over from Lake Huron, recovered in WM4, and then 1 that moved across the lake from the Traverse City area to WM5, and then 1 that was captured and stocked in MM7. So I don't want to make a whole lot of headway on or inference on this, but we are hearing a number of reports from mass marked steelhead in the streams as well. And so the main point here is that we're likely to see many more of these steelhead starting this coming season when they're age 2, and we are taking steps to plan accordingly. We're making steelhead a priority species for collection, so we'll likely see the number of steelhead collected go up, and we'll be collecting a calcified structure to make sure we can get age information on unclipped fish and wild fish to start looking at wild recruitment of steelhead. All right, so covered half the outline. The other half should take a bit longer. Chinook salmon, I'm going to review some results and then provide some new information. So some of the things we've talked about at this forum before in terms of spatial patterns and survival. This is a map summarizing the catch per unit effort corrected for number of fish stocked for Chinook salmon, which is an indicator of survival. These blue districts were consistently high, yellow districts were average, red districts were relatively low, and these purple districts were more sporadic in terms of their year class strength and survival of the stocked fish. So you can kind of see the general patterns we've seen here. Generally higher survival from western shore locations, low survival from MM6 and especially from Green Bay. The 2018 data were consistent with this. I didn't have time to update this map, but I did take a quick peek, and there was nothing to say that this is inaccurate. So this is still up-to-date information. And without going into too many details, some of the reasons why this may be the case could be differences in temperature between the stocking sites or forage availability. Wild recruitment, certainly there's a lot more of that going on the eastern shore. And then potentially predation, especially in systems like Green Bay that have a large walleye and cormorant population. Some more review in terms of movement of Chinook salmon. By examining the coded wire tag information, we've basically consistently seen that in spring and summer, the stocking location of a Chinook salmon has very little to do with where it's caught. So I typically show a number of these maps today. I just have one as an example. All of these red circles are where the fish were stocked, and all of them were landed at Frankfurt. So the circle size is proportional to the number of fish that came from that particular district, and you can see that they're coming from all over the place. And I could show you a map for Sturgeon Bay or Michigan City, and it all looked pretty much the same. We have seen that the autumnal movement is different. Recovery rates are in the fall, where very close to where they're stocked, so we do see a lot of evidence of natal homing. In the past, I've just shown this one figure from the 2011 year class. What I'm trying to do today is to show that this is really a consistent pattern for across year classes. So in all of these figures, you're looking at the proportion of fish captured in the stocking district by month, and basically you have age 1, age 2, and age 3 fish in each year class. These taller bars that you see in each of these figures are September. And so we're seeing when spawning season rolls around, we're typically catching stocked fish where they're stocked. And these lower bars are April through July and April through August, and that's reflective of that past map where we're looking at about maybe 10% captured in the district where they were stocked and 90% captured elsewhere. So important seasonal component to where Chinook salmon are moving. So moving into some updates from the past year's field collections. We annually look at the Chinook salmon wild recruitment. We do this by looking at the proportion of stocked to wild fish. Stocked fish are going to have that AD clip or coded wire tag. The wild fish will have an intact adipose fin. And coming out of the hatcheries, only about 0.5% of the stocked fish are unclipped due to error. I think 2 years ago we actually looked in the field to try to see if there was any evidence of fin clip regeneration. We saw none. Basically the percentage of fish that had a tag but no clip was the same as it was in the hatchery. So our interpretation is 99.5% of those unclipped Chinook salmon are going to be wild. And so just kind of in the interest of time to breeze through these methods, we essentially look at the month and statistical district specific catch rates, correct that for sampling effort and angler effort, and then average across statistical districts that have an adequate sample size of age 1 fish to get our percent wild. So this is typically we use a minimum of 10 age 1 fish recovered per district. And in 2018, these are the data that fed into this percent wild assessment. So the black fonts are going to be those that were included in the average. The gray fonts had fewer than 10 age 1 recoveries, and oftentimes it was like 1 or 2 or 3 fish. So, you know, for example, we don't want to include 100% wild when we know that's based off of 1 fish that we caught in Green Bay. So, the number that Nick provided, 60.4%, is coming as an average of these district-specific estimates of percent wild at age 1. And that value in context of what we've seen historically is kind of right on par with what we've seen maybe towards the higher end of the percent wild by year class at age 1. So the more interesting figure is this next one. So we use this percent wild information to then estimate the smolt production. So this figure is showing the estimated number of Chinook salmon smolts in millions, again by year class at age 1. The orange bars are going to be the stocked smolts. We know how many fish we stock. The blue bars are how many wild fish we're estimating from the percentage wild. And we can see that this 2017 year class, we had 3.5 million wild fish and estimated total of 5.8 million fish. That is going to be a little bit less than we saw for the 2016 year class, but kind of showing this increasing trend since the really low year class of 2013. And to just kind of highlight those findings, I'm just going to take those stocked fish out of this figure. This is now just showing the wild smolts, otherwise it's the same figure. And just a reminder, this 2013 year class, this was right after the 2012 cut in stocking. We also had experienced really dry spawning conditions that fall, and it was followed by a really, really harsh winter. So those factors likely contributed to this record low year class for Chinook salmon. The hypothesis that I'm looking at in terms of when I see these data, I'm wondering if these two subsequent year classes in every other year are some evidence of recovery. The reason why I'm maybe thinking this is the case is because if you look at the age distribution of Chinook salmon, and I'm going to show that in a little bit, a lot of stocked fish are age 2. You see less at age 3. I think a lot of those fish are spawning at age 2. Well, if there's a really weak year class here, maybe fewer 2-year-olds in this year class, potentially fewer here. We might be seeing some residual effect from that 2013 year class, as that value seems to be slowly creeping back up. The other thing I want to note is if we look at the 2006 to 2012, this yellow box is kind of what I'm viewing as the historical norm in terms of wild year class strength, ranging from about 3.8 to 5 million fish. And if we extend that box all the way over, we see that the 2016 year class was in that range. The 2017 and 14 year classes were pretty close. So even though we had two really low year classes, we're trending upwards back towards this historical norm. I'm not really intending to make any forecasts for the future, but that is the trend in the data at present. So one thing I want to bring up about this calculation is the treatment of fish that are stocked in Lake Huron. So typically the percentage of Huron-stocked Chinook salmon that are recovered at age 1 in Lake Michigan between April and August, we measure that for each year class. And we have been noticing that number is 95% typically. And for that reason, we've been multiplying that percentage by the number of fish stocked in Lake Huron and considering those fish to be part of the Lake Michigan Chinook salmon stock because they're in the lake feeding on Lake Michigan alewife. When we looked at the data in 2018, we saw a little bit of something strange. So what we're seeing here are the percentage of Chinook salmon that were stocked in Lake Huron but recovered in Lake Michigan by collection year. And you can see for the first 3 years we did this, it didn't really matter what age we were looking at. We were looking at 95% of those fish being recovered in Lake Michigan during the feeding season prior to the September spawning runs. We did see a little bit of a shift in 2017, but at the time we didn't think that it had to do with any real pattern because, as I mentioned, we didn't have any people out there in 2017 collecting in April and May. And so during these prior 3 years, a lot of those fish that we saw moving from Lake Huron, we captured in April and May. And that percentage is an average from April through August. If you take out half of those months, you're going to get a lower percentage because August is typically a transitional month. But we didn't have that issue in 2018. And so for age 1 fish, we still saw about 90% of those in Lake Michigan. But at age 2 and age 3, we saw fewer of those fish in Lake Michigan and more of them in Lake Huron. This could be an indicator of one of two things. It could indicate that fewer fish are moving over from Lake Huron. It could be, I guess, of 3 things. It could be that some of the fish are moving back at older ages and staying there outside of the spawning season, or it could mean that fish that were in Lake Huron and didn't move over are surviving at a higher rate. We don't really know, but we are, as a group, the PPR group is discussing how to handle this information. And there is some sensitivity to this. So just for example, if we were to use the age 2 value for the 2018 year, which was 68%, that 5.8 million estimate would drop to 5.3 million. Just because if we have less fish coming over, there's fewer stocked fish in the population, and therefore our percent wild is going to produce fewer wild fish. So it's not as simple as just taking an average value because there's typically a lot more age 1 fish than age 2 fish, more age 2 fish than age 3 fish because of mortality. And on top of that, our detection ability for age 1 fish is reduced, particularly for 2018. So the 2017 year class of Chinook salmon in Lake Huron, only about 100,000 of those received a tag. Starting in 2018, they're all going to be receiving a tag again. So we should have a greater number of recoveries of those age 1 fish moving forward. But it's just a potential shift in what we've been thinking about these Lake Huron fish. And like I said, we haven't come to any conclusions in the PPR group, but there have been some discussions as to how to incorporate this information by perhaps looking at more age-specific data in the estimates. So I'm going to present here another figure, and this is percent wild of Chinook salmon at all ages. As I mentioned, we typically see more wild fish at older ages. So this overall percentage climbs upward to 68% when we look at all age Chinook salmon. We see a similar number this year in Lake Huron. And the gray font here is fewer than 20 total recoveries. So we typically see a lot more fish at age 2 and 3. Spatially, we can see maybe a little bit higher wild on the eastern shore than the western shore. Those numbers become a greater disparity in September when the wild fish are returning to the eastern shore where they likely spawned out. So that's kind of what we see for Chinook salmon wild recruitment. I do want to move along here and just show one figure we have for looking at Chinook salmon length at age. This is highlighting the same pattern that Nick Legler talked about a little bit ago. Instead of looking at the weight, here we're looking at Chinook salmon length at age 1. That's this blue figure, and that's really tightly coupled with the year and older alewife density in any given year. That's the orange line, courtesy of Dave Warner at USGS. We see a similar coupling for lengths at age 2 and age 3. So there really is this strong evidence that the food supply is really going to be tightly linked to the length of these animals, and that's a pretty strong indicator that food is typically limiting. And as Nick put it, when you get this kind of big year class, you get a nice bit of growth, and I imagine based on what we've seen in our data and what we've seen from the alewife abundance, that these both are going to climb for the next year here. So last time we were at this meeting, there were some questions about comparing the growth of wild and stocked Chinook salmon. And so this is a figure, I'm going to show a series of figures looking at the total length versus the age for wild fish in blue, stocked fish in red. The growth rates are actually pretty parallel. They're increasing at a similar rate. But the length at age is higher for the stocked fish. And that's because they're coming out of a hatchery. They have more ideal conditions than the wild fish in terms of growth. And so they have this leg up, and it appears that that leg up persists throughout the life of these animals. We see that in the 2013 year class, 2014 year class, and the 2015 year class. And I imagine we'd see it for the subsequent year classes, although I didn't have time to update these figures to include those. And so what this boils down to is if you actually look at the age distributions of these fish, here I just have age and then the percent of stocked and wild fish in our collections that are at each age. This is 2012 through 2017, just shy of 26,000 fish feeding into this. And so for the stocked fish, we can see this progression of, from age 1 to age 2, and then it declines as you get to age 3. For wild fish, we actually see that increase as you get to age 3. And then age 4 and 5, we have almost 7% of those wild fish are age 4 or 5, only 1% of the stocked fish. I think this is all related to this lower length at age for wild fish. It could be that there's an angler bias towards larger fish, and larger fish for wild fish tend to be age 3, and for stock they tend to be age 2. Or perhaps in addition, there could be this tendency for wild fish to spawn at older ages. And this makes sense biologically. If you have animals that are smaller, they are less likely to be mature. And for Chinook, that decision point's going to come at either age 2 or age 3 typically is what we see. So I think there's some evidence here that we do see backing up the fact that we see more wild fish in the fishery as we look at older ages. All right, I'm going to switch species and move on to lake trout. So some results for lake trout. I know Chuck Mendengian highlighted this in his talk. Overall, we saw 30% wild in Lake Michigan. The way that number was computed was just taking all the fish we captured. I want to note that if you consider each statistical district an independent unit, if you averaged across all statistical districts, that number is 23%. So I would concur with Chuck's estimate that 20% may be right around the ballpark of what we actually see in the lake. Because we do have higher collections in the southern basin than the northern basin, and that's going to drive up this number. Percent wild was considerably higher in the southern area, an average of 34% for these districts compared to 2% for the northern districts. And then percent wild was about 65% in Lake Huron, which is showing a continued increase. And so I'm going to show you these data over time. This is the percentage wild lake trout in Lake Huron. Southern Lake Michigan and Northern Lake Michigan, color-coded as you see in the map by collection year. And so we do see that number keeps climbing up for Lake Huron and Southern Lake Michigan and is remaining relatively stable and low in Northern Lake Michigan. Now, these increases could be due to lower stocking rates of lake trout, or they could be due to increased abundance of wild lake trout. And so I took a stab at calculating a catch per unit effort in our data set. On the car ride down yesterday, we look at the wild trout catch per unit effort by year, and we can see it's a little more sporadic for Lake Huron, but for Southern Lake Michigan, that actually tracks the percent wild fairly nicely. Slope is not as steep, but there's certainly some evidence here that that increase in percent wild is at least in part due to an increase in the actual abundance of wild fish and is not just related to reduced stocking. So that's a good sign for lake trout. With respect to how this affects anglers, I was able to update this analysis, presented this figure I think 2 years ago based on data from 2015 and 2016. So now we've got data from 2015 through 2018, increases our sample size to about 5,600 fish, and we have a little more confidence now in these results. So the offshore contribution, what you're seeing here is the percent of angler catch in each of the jurisdictions as well as Lake Michigan on a whole that come from offshore versus nearshore stocked lake trout. The offshore locations are in blue, nearshore is red. And we see about 2/3 of stocked lake trout captured by anglers in Lake Michigan were stocked offshore. This really demonstrates that the offshore stocking does benefit the nearshore recreational fishery. And we see that the two offshore stocking locations that are contributing the most, we see Southern Refuge and Julian's Reef really kicking in a lot of fish. Indiana and Michigan had the highest contribution in nearshore stocked fish, and that's not really a surprise because most of the nearshore stocking in Lake Michigan occurs in Michigan and Indiana. Michigan was about 50-50 offshore to nearshore. And this particular figure doesn't include how many fish were stocked, so we did look at that, and it's not that this figure, this isn't just because we're stocking a lot of fish offshore. So this is the same data, except we're now correcting for 100,000 fish stocked, correcting for those stocking numbers. This is going to reflect actual return rates. And what we see is that Julian Reef had the highest return rate from each state, and the Southern Refuge has the second highest return rate in each state. So it's not just the total number of fish, it's that the fish that are stocked offshore appear to be surviving at a better rate than these nearshore fish, or some other component that's resulting in them being this really important part of the nearshore fishery. The other thing I want to note is that this figure is intended to show relative contribution in each of the jurisdictions, but you can't really compare across jurisdictions because it's not corrected for sampling effort. Sampling effort was a lot higher in Wisconsin and Michigan than in Indiana and Illinois. So if you were to include that, you'd see the values pop up for those two states. So keep that in mind. One other thing we were able to do in 2018 was develop a preliminary lake trout movement matrix. This is updating the last matrix, which was developed by Rob Elliott et al. In 2003. Matrix looks at recreational fishery only, and from only the mass marked year classes from 2010 through present. What we basically found is that most lake trout are near the stocking district or adjacent districts, and we're working up the assessment survey matrix now. I'm actually pretty close to having that done, just didn't have it in time for today. But that will provide a better representation of movement from offshore locations like the Southern Refuge, just based on the sampling design of the assessments. So just to kind of highlight some of these findings, I'm going to show a series of maps. This is showing lake trout stocked in Illinois and the percentage of recoveries. You can see it's mostly Illinois, Indiana, and Southern Lake Michigan. These are fish stocked in Indiana, pretty similar results, although more on the eastern shore than the western shore. We look at fish stocked in the Northern Refuge, and we see close to 70% are staying real far up north. These are the coated wire-tagged fish, so we don't see a lot of those occurring in the southern part of the lake. That gets at one of the questions that was asked earlier, are the wild fish moving from north to south? These aren't wild fish, but the stocked fish aren't moving, and therefore I don't think there's much reason to believe that the wild fish would be moving from north to south either. I want to say that for the assessment surveys, we're able to look at this for a related project, and here we see circles that are in proportion to number catch, and it really aligns really closely with what we see with the updated matrix from the recreational fishery. All right, fish stocked in MM5, mostly MM5, MM6, a little bit in MM7 and MM8. Fish stocked in MM7 and MM8 really strongly. They're staying local. And then the southern refuge, this is probably where this preliminary matrix is weakest. We do see a lot of movement, but what we don't see is a lot of fish in WM5, which is where the southern refuge is. And if we look at the LWAP data, these big red circles are actually assessments conducted on that mid-lake reef complex. So once we include these data, these fish, which comprise, I think, about 40% of the fish you see in this figure, are going to be included in that WM5 area, and that's going to kind of change the perspective there. But aside from that, we do see, again, pretty strong similarities. Southern two-thirds of the basin getting a lot of fish near shore, and we see kind of a similar distribution of those fish in the recreational fishery. So I'm looking at my timer. I don't have too much time left, but I think I do have enough time to touch a little bit on what we've seen with sea lamprey. So we have the opportunity in our data set to look at sea lamprey wounding on all the salmon and trout that we see, and we take these data as a matter of course. So it's been interesting to kind of look at the potential for other salmonines to function as hosts for sea lamprey. This is a figure showing the number of A1 through A3 wounds per fish regressed against total length using a logistic function. And the percentage values that you see here, boy, I almost just broke out in a dance there. The percentage values you see here are the asymptotic values, so that's where this line kind of flatlines. That's the percentage wounding you'd see when size is no longer a factor in terms of lamprey wounding. And so in Lake Michigan, this isn't terribly surprising. We see the most wounding on lake trout, some moderate wounding on brown trout and Chinook salmon, and pretty negligible wounding on coho salmon and rainbow trout. Another thing we can look at from these models, we get this beta parameter. This is the inflection point of these curves, and that you're going to see this. These are lengths in millimeters. That's the length of a fish at half the value, where you have wounding at half the value of the asymptote. And so it basically is an indicator of when lampreys start to really feed on these hosts. And in Lake Michigan, we see pretty consistent numbers across all the species. So that may suggest that any preference for size isn't species dependent, or that there's just a pretty high availability of large hosts in the lake. We see a pretty different pattern in Lake Huron. We didn't have enough data to look at rainbow trout, coho salmon, or brown trout. But for Chinook salmon and lake trout, we actually see about a little more than 2 times the wounding rate for Chinook salmon compared to lake trout. And this was not just in northern Lake Huron, this was throughout the lake. So we'll touch a little bit more on that, but that's certainly an indicator that Chinook salmon are functioning as hosts for these animals in some circumstances. The other thing we noticed is these beta values. They were consistent between species within Lake Huron, but they were 80 to 140 millimeters lower than the Lake Michigan values. So that suggests that lamprey are attaching onto smaller hosts in Lake Huron. Could be because there's a higher lamprey to host ratio, or just a lower availability of large hosts in Lake Huron. So one of the other things we noticed, and this is kind of the impetus for the proposed research I mentioned looking at physiological effects, is that very few Chinook salmon have healed wound types. So this is a figure for Lake Michigan, and we see similar data in Lake Huron. Wounds per 100 fish from A1, A2, A3, and A4 wounds. So for those not familiar with the wound classification scheme, basically these A1 wounds are fresh, and then these are various stages of healing. For lake trout in green and brown trout in brown, we see that those numbers are consistent across the healed wound types, and for lake trout actually increase. But Chinook salmon, there's a distinct drop-off, and we don't see a lot of those healed wound types. So because there's many more fresh than healed wounds in Chinook salmon, this could be suggesting greater mortality from lamprey attacks. That's one potential reason for these data. We don't know that that's the case, but one thing we might be able to do to touch on that is see if there's a greater effect on the physiological condition of Chinook salmon that have fresh wound types. And that's what one of the things we're proposing to do. The other thing that it suggests is that by looking at A1 through A3 wounds, we may actually be underestimating the effect of lamprey on Chinook. So lake trout, if you only look at A1 wounds, those fresh wounds, lake trout only has 1.5 times the wounding rate in Lake Michigan as Chinook salmon, as opposed to 4 times higher when you include A2 and A3 wounds. So That's kind of a summary of what we've been doing with the Great Lakes Fish Tag and Recovery Lab. 6 key take-home points. We see that Chinook salmon natural production is slightly below the baseline average, and that movement from here on may be shifting. Chinook length at age has been pretty tightly coupled with alewife and differs between wild and stocked fish. For lake trout, the reproduction appears to be increasing, especially in southern Lake Michigan, but it's not quite at restoration targets as Chuck's talk focused on. And lake trout stocked offshore are pretty important to the recreational fishery. Sea lamprey wounding varies by species. Chinook salmon appear to be an alternate host to lake trout for sea lamprey, although lake trout is still the primary host. And then A1 through A3 estimates of lamprey wounding may underestimate lamprey attack rates on Chinook salmon. So with that, I'd like to thank you all very much for your attention. And if you don't want to go get hors d'oeuvres, I'll be happy to take questions.